Hello everyone, let's go over some of these questions. You already have short answers to the final sort of answer question of these, but I'll write some written answers here. Number 1, given cosine x is 4/5 with x in the fourth quadrant, find the remaining 5 trigonometric function of x. What you can do is just knowing that it's in the fourth quadrant, you can use the quadrant for that, or you can just draw a triangle. Let x to be one of the two angles other than the 90 degree. And then cosine is adjacent over hypotenuse, so 4/5. And then you're going to find the third length by Pythagorean theorem. So 5 square is equal to 4 square plus the third one. I'm going to put a question mark a square. So as a result, this is 25, this is 16. You take 16 to the other side, it's 9 is equal to the question mark a square. So question mark is 3. So then question mark is 3 right here. Okay. So now you have all the sides and you can find the remaining 5 trigonometric functions. So sine x is equal to opposite over hypotenuse. Cosine is already given, so tan. So I'm going to list cosine because it's going to help with the other ones. So, by the way, knowing sine is on the fourth quadrant, so you put -3/5 because they said the angle is on the fourth quadrant. So cosine x is positive, given, and it's on the fourth quadrant. You are expecting cosine to be positive. Tan x is opposite over adjacent, so 3/4. And then knowing that it's in the fourth quadrant, it would be negative. So then from here, if sine is -3/5, cosecant is -5/3, just reciprocal of that. If cosine is 4/5, secant is 5/4. If tan is -3/4, cotan x is -4/3. Okay, let's do another question. So I'm gonna do number 4. 4 and 5 you just use formulas, or 7. So depending which one, then you're gonna use the identity that is related. I'm gonna do 4. 4 is cosine of s plus t. First, you need to write the formula out, or identity out. Cosine s, cosine t. If it's a plus here, it's going to be minus here. And then sine s, sine t. So what's been given is sine s. So this element, sine s, is given, and that's 1/3. Cosine t is given, that's 3/4. I need to find the rest. So let's work with angle S first. So if this is S, opposite over hypotenuse. So as a result here, let's say this is a question mark. And again, I put question mark because I want to eliminate the number of variables that I'm using here. So you're looking for cosine s, so you need to have the adjacent. You need to use hypotenuse and the other leg using Pythagorean theorem to find the question mark. So question mark a square plus 1 squared, the 2 legs, is equal to hypotenuse square. So subtract 1 from both sides. Question mark square is equal to 8, 9 minus 1. So as a result, question mark is square root of 8, which if you simplify is 2 root 2. So we got the question mark to be 2 root 2. And then you're going to plug it back to the cosine. So that would be, knowing that it's in the second quadrant, you're going to put adjacent over the hypotenuse, negative 2 root 2 over 3. And then using the same method, you're going to find sine t basically. So given that t, cosine t is 3/4, so adjacent over hypotenuse, you're going to find the other side, which is root 7. Knowing is in the first quadrant, so it's going to be opposite over hypotenuse and positive, of course. So you combine them, you multiply the first one, negative 6 root 2 over 12. And multiply the second one, 1 root 7, which is just root 7 over 12. The denominators are the same, so you combine them. Okay. Next question, something like number 8, it says pi over 12. You need to be creative. You can change it to degree and come up with what could be the two angles that you need to add or subtract, or you can just think about them as a radian. But basically, pi over 12 is equivalent of, that makes it easier, it's equivalent of 15 degree, which you can say 45 degree minus 30, or you can just write it as pi over 4 minus pi over 6. So to find sine x, so sine of pi over 12 is the same thing as sine of pi over 4 minus pi over 6. And then you're going to use the identity for the difference. Sine pi over 4 cosine pi over 6 minus sine pi over 6 times cosine pi over 4. And then you're going to substitute for each one. So you would say root 2 over 2 times cosine of pi over 6 is root 3 over 2 minus sine pi over 6 is 1/2 times cosine of pi over 4 is root 2 over 2. Then you simplify from here. You have 4 for the denominators. For here you would have root 6 minus root 2. Combining them, you have root 6 minus root 2 over 4. Okay. So for the true falses here, just think about the rules you had to this point. So let's see if it applies. So like sine of 88 is the same thing as 2 times 44 degree. Double angle of sine is 2 sine theta cosine theta. So using the rule of sine 2 theta is 2 sine theta cosine theta. In this case, theta is 44 degree. So that's why it's true. 11 is false because secant is the same thing as 1 over cosine negative 82 degrees. Cosine is an even function, so this is equivalent of positive 82, cosine of positive 82 degree, which is going to be positive secant. That's why this is false. And the last one, 62, is the same thing as cosine of 29 degree plus 33 degree. That's fine, but then if it's cosine, this sign right there must be negative. If it's a plus here, it must be a minus here, so that's why it's false. Okay. So express the identities as of sine or cosine. I'm going to work on number 14. Seems longer, so I'm going to do that for you. 1 minus cotan square is cosine square theta over sine square theta. Cosecant is 1 over sine square theta. So you write it in terms of sine and cosine and simplify. This is a complex fraction. You need to simplify the numerator by taking common denominator, sine square theta. You multiply top and bottom by sine square. So it's sine square theta minus cosine square theta over 1 over sine square theta. So to cancel and simplify the complex fraction, you would say numerator divided by denominator is the same thing as numerator multiply by, so you write numerator multiply by reciprocal of denominator. So that's why you have sine square minus cosine square left. Again, if you have complex fractions, you're going to simplify numerator, simplify denominator. In this case, denominator is already simplified. Then you say numerator divided by denominator is the same thing as numerator multiply by reciprocal of denominator. Instead of divide, you should multiply, but by reciprocal. Okay. Let me work on some of the identity questions. Something like number 18. I need to go from one side to the other. Sometimes if it's difficult to do that, then you can simplify both sides depending to how much you know of the basic identities. So in this case, 2, I'm going to write instead of tan, I'm going to write sine x over cosine x. Instead of secant, I write 1 over cosine. Instead of cosecant, I'm going to write 1 over sine. And then sine and sine cancels. So what I have is, give a denominator of 1 to 2. So it's 2 on the numerator, cosine square x on the denominator. That is the same thing as 1 over cosine is secant, so 1 over cosine square is secant square x, but since it's 2 here, so you're going to put 2 right behind that. So there is an identity that says secant square is 1 plus tan square theta. tan square, in this case x. So substituting that, you multiply 2 in is 2 plus 2 tan square x. Checked. Okay. So now some problems from chapter 6.